Good evening. In continuation to our topic on adders, earlier we had discussed the half adder. In this presentation, we are going to discuss the full adder. In the half adder, we had seen that it adds only 2 bits, and whereas in case of full adder, it is able to add 3 bits, and the third bit is the carry bit, which is generated from the carry generated by the lower bit additions. So that is what we have written over here. It is a combinational circuit that adds 3 bits, and the third bit is the carry bit here, which is generated from the lower bit addition. So this is the logic symbol in which we are having A and B as the regular inputs, and this third one is the carry input, and we have the outputs as sum and carry output. This is the logic symbol, and in the truth table you can see that. So let us start from the first one. When all three are 0, obviously the sum will be 0 and carry will be 0. When there is one input which corresponds to 1, we are having sum 1, carry 0. And in case of 0, 1, 0 as inputs, we have sum, again it will be 1, carry will be 0. Now when we have 0, 1, 1, in this case we are going to get the sum as 0, and there will be carry which will be generated, and it will be 1. Next we have the combination as 1, 0, 0. Here we will have sum as 1, carry again it will be 0. Then we are having the combination as 1, 0, 1. Here again we will get sum as 0, and a carry will be generated, and so here we have written carry as 1. And in case of input combinations as 1, 1, 0, sum will be 0, carry will be 1 again, and finally when all three are 1, that is 1, 1, 1, here we will have sum equal to 1 and carry also equal to 1. So from the truth table, now we have written the equation for sum as given and for carry as given. So now I want you to let you know that how I have written this equation. So for writing such type of equations in these logic diagrams from the truth table, you have to simply consider the truth table, and these equations, they correspond to the outputs. If you see the output corresponding to the sum, what you have to do is you have to write the terms. That is, you have to write, looking at this column, the minterms corresponding to the sum output. So if you recall the concept of max term and minterms, the minterms are those which correspond to 1, the values which correspond to the 1 output. So if you see this one here, this corresponds to A bar, B bar, and Ci means that is the carry input. So this one corresponds to A bar, B bar, Ci. So that is what we have written over here, A bar, B bar, Ci. Then we have A bar, B, Ci bar, A bar, B, Ci bar. So likewise, again, when considering these two ones, we get the values as A, B bar, C, I bar, A, B, Ci. So similarly, we have written the equation for carry. As you can see, this one is equal to A bar, B, Ci. A bar, B, Ci. Okay, let me write this as Ci. Here again, all these are Ci. So likewise, we have written the sum equation and the carry equation. Now there is an interesting and important point here. You can see the equation corresponding to the sum cannot be further simplified, whereas the equation corresponding to the carry can be further simplified by either using the laws of the Boolean algebra, or we can simplify it by using the Karnaugh mapping. And this we are going to perform. Why? Because mainly we have to draw the circuit diagram, and if we get the simplified equation for any of these two, that will help us in drawing our circuit diagram more easily. So let us simplify the circuit diagram for the carry equation, so by using the Carnot mapping. So what I am doing here is, okay, now having a look at this K map, I have already simplified this for you. Here you can see that I have plotted the ones corresponding to the minterms. For A bar BCI, this is A bar, this one, A bar B CI. Then we have A B bar CI. We have A B bar, A B bar, and this is C input. Okay. Then we have A B CI complement. A B CI complement, the upper one here. Then we have A B C input, A B C input, this one. Then we have done the grouping of ones and we get the values as this is B C input, then AC, that is AC input, and then finally AB. So I have written the carry equation like this. So you can see from this equation of carry and from this equation of carry, we have simplified this equation and we got this equation. Now this will help us in drawing our circuit diagram, and it has become easy for us to draw the circuit diagram now. So again, before going to draw the circuit diagram, again there is one more interesting aspect when it comes to the equation of sum. As you can see, the sum equation is, let us consider the sum equation again and write this separately again, and let us see how interestingly we can use it to reduce it into the form of exclusive OR output values being produced. So from the equation of sum, you can see that first I have written the equation of sum like that, then I have taken the C, that is carry input, common, and ultimately when you solve this, you are going to get that equation like this. This x here corresponds to the x here corresponds to, earlier I had written AB plus A bar B bar, that was wrong. So x corresponds to basically A bar B plus AB bar, and when you solve this equation for sum, you are going to get equation in the form of like this, that is we are having the carry input which is connected to the x input, and x is what? It is the exclusive OR between A and B, like this. So now this will help us in drawing our circuit diagram. So we will consider this equation for drawing the circuit diagram, okay, for sum. And for carry, I have written the carry equation. It can be written in this way. So now let us take this sum equation where Ci is the carry input and this is getting exclusive OR with the x input. X is what? Let us replace this x. So it can be written as sum is equal to A bar B plus A B bar. It is getting exclusive OR with carry input. So this is basically, we have taken A, B and okay, and this is AB, and from here again we have to take the carry input CI. Now it is connected via the exclusive OR. So this is what the sum output is. As you can see, and here you are getting the sum output as per your equation being shown. So now considering the carry equation, in which this, have a look at this. So what I am doing is I am taking out the input from here, okay, and this one we have to multiply with the carry input. So this one we have to multiply with the carry input. So I am multiplying this with the carry input. So till here we have solved this part. Then we have to add this with the AB. So first we have to take the AB. Okay, this is A, and from here I am taking, this is B. Okay, this is AB, and this is so we have to mainly we have to get to know the concept. So I am not paying much attention to the how neatly it is being drawn. Okay, so here we are getting the carry equation now. So this is the circuit diagram which we have drawn using the exclusive OR gate and the AND gate, like we had done in the half adder. So you can see that if you have to write the output now, this is equal to, here you are getting this A bar B plus A B bar, okay, and here you are having the CI input. So this is getting exclusive OR. So what we have is CI, and that is getting exclusive OR with this A, like this. So this is what the sum output is. And for carry you are getting, for carry you have this A into B, okay, and this is getting added to, here you are getting, this is A into B, and here you are having, from here you are getting, this is A bar B plus AB bar, A bar B plus AB bar, okay, and from here is CI. So this is getting multiplied with CI, and these two added. So this CI A bar B plus AB bar. So this is what you can have a look at this, AB plus CI into. So this is how we have drawn the first whatever equations we have obtained, the sum equation and the carry equation. We cannot simplify this, means we cannot further reduce this sum equation, so we haven't reduced that, but yeah, we have simplified that in terms of when we had to draw the circuit diagram. So we had simplified that, but we had simplified the carry equation because now we'll draw the circuit diagram using this equation of carry, which we had simplified using the K map. Okay, earlier we had just used this equation, the sum equation, its simplified version, and the simplified version of the carry equation. Here this was the simplified version of carry, this was simplified version of sum, and using that we have drawn this circuit diagram. Now we'll consider the carry equation, this one, Okay, and this sum equation, and using these two now we will draw the circuit diagram, which will now consist of the AND, OR and NOT gates basically. So now you can see that I have written both the equations again. The carry equation, which is now the simplified one, that I have written carry is equal to AB plus A CI, that is A the carry input CI plus B the carry input CI BCI. And for sum I have taken the equation, the very first equation, that is A bar B bar CI plus A bar B CI, A B bar CI complement, here also A bar B CI complement, and A B CI. So now we'll draw the circuit diagram. So first let us take the carry. So or let us draw the sum one, okay, because we'll have NOT gate in that. So suppose here we are having A and this is the NOT gate, okay. Let us take the for all of them, okay, B, and similarly for C also, okay. Now first we have A bar B bar CI, A bar B bar, okay, I'm taking this one, A bar B bar and CI. So I'm taking this, fine, and we have to multiply. So here we are getting A bar B bar A bar B bar, okay. Then we have A bar B CI complement, A bar, from here I can take A bar B, A bar B CI complement. So this is A bar B, from here I am taking B, okay, I am following the logic only, A bar B and CI complement. So from here I am taking the CI complement, okay. So this is A bar B complement. Then you have A B bar CI complement, A okay, A B bar A, I got A, so now I have to take B bar and CI B bar. So B bar and CI complement, B bar. So for B bar I am taking B bar from here, okay. So this is B bar, okay. Just focus on the logic, okay. So this is now, still there is one remaining, that is CI complement, CI complement. So I am taking CI complement from here, I am taking the CI complement, okay. So then we have ABC. So ABC should be easy for us. So from here we can take A, this is A, then we have B, from here I can take B, and then C. C from here I can take C. Okay, fine. So this is A, B, then okay, and we have to add all these. Okay, then you have to add all this. So okay, then okay, so for that we have to connect the OR gate. So this is the output for sum. Then now carry is equal to AB plus ACI plus BCI. AB plus ACI plus BCI. So A B, we have to connect the AND gate now. So for that, let us take A. I'm taking A from this, A coming over here, so we can take A from here. I'm taking A. Okay, AB plus AB. So this is A. Now I have to take B. So this is B coming over here. So B. Okay, this is AB. Now AC. AB plus AC plus AB. Now AC. So again, this is from here running A and here. So I'm taking A. This is A. C. So C again, I can take it from here. This is AB. Okay. Oh, we have to add these also. Okay, fine. Then we have AB plus B CI. Okay. Then B. Let me take B from here. So this is B. I'm taking B. Okay. This is B and CI. So I'm taking CI from here. Okay. Fine. So this is B, right? And then as you can see here, we have to again add these three. So I'm taking, okay, this is A. Okay, so again we have to connect the OR gate. And this is our equation for the carry, and that is equal to, we have AB plus A plus B, and here you have sum equal to, that is A bar B bar CI plus A bar B complement plus then A plus A B. So again, it is my request to all of you, just focus on the how logics, because here it matters is that how the, looking at the logic we have drawn the circuit diagram, because when it comes to drawing of such logic circuit diagrams, you cannot just memorize them simply having a look at that. For that, you have to understand the concept and the logic, how these connections are being connected. So again, I suggest all of you to pay attention to the logics for which I have making use of that. I have connected these circuit diagram for the full adder. So this is about the full adder, and if you have any query, you can give me in the comment section, and whatever your suggestions are there, I welcome those suggestions, and please do let me know about the quality of lectures. Thank you.